Here's another test that you may find handy from time to time. It's called the root test. And let's set this thing up. We're going to let the sum of the 8 k's be an infinite series with non-negative terms. And I'm going to let rho equal the limit as k goes to infinity of the kth root of a sub k. Now, very commonly, depends on what book you're using, very commonly we see rho equals the limit as n goes to infinity of the nth root of an. This idea of n's and k's is kind of irrelevant. It just depends on what book you're using and what author at what time decided to use what index. So in case you haven't noticed, I'm kind of bouncing around between different indices. It's not really important what it is, and I want to make sure that you understand that. As long as you know what you're dealing with, I mean, you can make these i's if you want, which is another common way to represent them. The indice is not important as long as you're consistent with whatever indice you're using while you're working out a particular problem. So, rho is going to be equal to the limit of using this notation, the kth root of ak, of this sequence. So, if we have a situation where rho is between 0, or actually greater than or equal to 0, so it can be 0, but strictly less than 1, then what we have is this infinite series is in fact convergent. And you notice here I didn't write this k equals 1 to infinity. Whenever you see it written like this without the indices written, that it's just like a typesetting shortcut. The n or k equals 1 to infinity, or n, whatever your indice actually is, it's understood to be from 1 to infinity. Now, if you have a situation where you take this limit and you end up with rho greater than 1, then the series is divergent. Now, if rho equals 1, then once again, the test is inconclusive. So let's go ahead and take a look at this. Now, if you look at this example, if you're going to use the integral test, this would be interesting to try to integrate. It's not going to necessarily be real easy. So the root test makes a lot of sense because this thing is raised to the kth power. My indice is k equals 1 to infinity. So what I want to do is take a look at the limit as k goes to infinity of the kth root of k plus 1 2k to the k. And what that is that's the limit as k goes to infinity of k plus 1 to the 2k, because that's the result of taking the kth root of something raised to the k is the radical goes away. Now, this will go to infinity over infinity, so based on L'Hopital's rule, this is going to be the same as a limit as k goes to infinity of 1 over 2, which equals 1/2. Now, this is what I'm thinking of as being rho, and rho is less than 1 in this case. Actually, it makes a lot of sense to do absolute value of rho. But anyway, rho is less than 1. Therefore, this series is convergent. So looking at another example, I have this series k over k plus 1 raised to the k squared. Okay, so I'm going to take a look at the limit as k goes to infinity of the kth root of k over k plus 1 to the k squared. Well, that's going to end up being the limit as k goes to infinity of k over k plus 1 to the k. I'm going to write this a little bit more suggestive form. This will be equal to the limit as k goes to infinity of 1 over k plus 1 over k to the k. And hopefully when you look at that you go, ah, and then you see where it's going. I'm going to rewrite it one more time. And if you're not seeing where this is heading, then you probably will now. 1 plus 1 over k to the k. Notice that as k goes to infinity, both the numerator and denominator are defined. None of these are 0. So I can look at these as individual limits. So this is actually going to be the same as 1 over the limit as k goes to infinity of 1 plus 1 over k to the k. Well, that's e. So this whole thing is simply 1 over e. Now, 1 over e, again, I'm thinking this as being rho, that's less than 1. Therefore, the sum k equals 1 to infinity of k over k plus 1 raised to the k squared is in fact convergent. Now, I am not saying, I'll make sure you're okay on this, I am not saying that this will converge to this. That's two different things. That's not actually what I'm saying at all. What I'm saying is that because the limit of the sequence goes to 1 over e, which is less than 1, that the series will in fact converge. I'm not making any claim of what it will actually converge to, other than I know it will converge to a real number.